Hello everyone, hopefully you're doing well. We come back with chapter two. If for any reason you missed lectures on chapter one, intermediate algebra for where we use reference book textbook Ellen Martin Gay 8th edition. Strongly advise you to watch the previous videos where we went over real numbers and algebraic expressions, where we introduced real numbers and algebraic expressions. So in this video, we're going to start with chapter two, equations, inequalities, and problem solving. Without further ado, I think it's better that we complete this video with only section 2.1, linear equations in one variables. In other videos, we're gonna introduce you to problem solving, formulas and problem solving, linear equations and problem solving, compound inequalities, absolute value equations, and absolute value inequalities. But let's focus on linear equations in one variable. So the objective is to solve linear equations using properties of equality, solve linear equations that can be simplified by combining like terms, solve linear equations containing fractions or decimal, or we can recognize identities and equations with no solution. So an equation is a statement that two expressions have equal sign. I think we went over it in the previous video. If you have equations with any expressions with an equal sign, we can call it equations. For example, we need to solve for something. When we solve algebraic equations involving finding values for a variable that make the equations equal for, we can ask this question: for which value of x the left side of these equations is equal to the right side to the equations? Because 2x plus 5, you see 5 on the left is way bigger than only one on the right. But what value of x would make this statement true? So that's what we're gonna learn how to do in these sections. We're going to solve linear equations in one variable. A linear equations in one variable can be written in the form I just write, use the examples, ax plus b equals c, where a, b, c are all real numbers, and a cannot be equal to zero. If a equal to zero, then there is no x to solve for. So if there is no power greater than one in the expression, then it's a linear equations. So if we have x minus 3 equals 7, linear equations. If we have 3x plus 8 equals 0. If we have, I'm gonna just put some few examples. If we have 2/3 of x minus 7 equal 11, or if we have 3 minus 5x equal 10x, those are all algebraic equations, or you said just equations. They are linear equations because the highest degree for x is only 1. X power 1. There is no x power 2, power 3, power 2, 4, etc. So because you only have x in the expressions, we call it linear equations. And you could have linear equations in many variables. Like you could have any linear equations with x and y, but in this case, it's only in one variable. You can only solve for x. There is only x on those expressions. That's why we call them linear equations in one variable. Addition and subtraction, property of equality. So addition of property of equality, if a, b, and c are real numbers, then a equal b. If a equal b, then if you add the same number to both sides, this would be equivalent. For example, if I have 5 equal 5, if I decide beside my 5, if I decide that my on top of my 5 equal 5, I decided to add 2 to it, for example. You see, if I add 2 to both sides, if I add C to both sides, the equation is still the same. 5 equals 5 or 7 equals 7 will give me the same. It's the same for multiplication. If I have 3 equal 3, if I decide I do 3 times 2, equal 3 times 2, answer would be the same because it will be 6 equals 6. So they are all equivalent with knowing that the number we multiply with is not equal to 0. Now, if they ask you to solve those equations, the first thing to do is to try to isolate the x. When I have x minus, this is what they ask you to solve. First of all, when I see x minus 4 equal to 7, I need to isolate the x, keep the x only on one side. And here, it's much easier for me to keep x on the left, so I need to get rid of negative 4. But how to get rid of negative 4? The only way to get rid to negative 4 is to add a 4 to negative 4. Negative 4 plus 4 give me 0. Because I learned previously, if I add the same thing to both sides, I don't change my equation. So I can add 4 to both sides. That means my equations remain the same. So that's why I have x, negative 4 plus 4 is gone, but on the other side, I am going to have 11. So if x is equal to 11, then this statement x minus 4 equals 7 is true. You can verify it if you want. Now, remember, if x is 11, then we're going to have 11 minus 4 equals 7. 11 minus 4 is really 7 equals 7. This statement is true. The same. First of all, on B, because I see that I have two constants, what I would do, if I have negative 3.2, negative 6.6, we said when we have the same sign, we add and keep the sign of the sign. So we're gonna have negative 9.8. So you agree that we're gonna have y minus 1.2 equal negative 9.8. Okay. I reduce. You need to always simplify. Simplify your equations to the lowest term. So simplify as much as possible. Now we need only y on the left. Isolate the y, isolate your variable. Because here the variable is y, I'm gonna isolate it. I'm gonna keep it y. So what I would do is get rid of my negative 1.2. How to get rid of it? Is adding positive 1 to it. Negative 1.2 plus 1.2 give me 0, but I cannot just go and get rid of it like this. I need to add it to the other side as well. So that's why when I add, I have y left in this side. Negative 1.2 plus 1.2 is gone. So we're going to have negative 9.8 plus 1.2. It gives us negative 8. It gives me negative, it's really give me negative 8.6. All right. Now, having it that way would change a lot of things because this is the answer for B. All right. This is the answer for B. We're gonna just continue with some of the examples. We have plenty of examples here. The access to solve. First of all, combine the x's. 6x minus 5x gives you what? Yes, that's only give me 6 minus 5, give me x, 1x plus 8. On the other side, 8 minus 3 give you what? 5. Yes, I give you a small voice because here what we do, we solve linear equations that can be simplified by combining like terms. So that's what we do. Now, because we have 8 on the left and we need to have only the variable x on the left, we need to get rid of 8. How to get rid of it? Because we had plus 8. The only way to eliminate plus 8, we need to subtract 8. So whatever you do on the left, you must do it also on the right, not to change anything from your equations. So in this case, we have x left, and 5 minus 8 is what? Negative 3. I hope you remember those. I hope you remember that's negative 3 on this one. All right. Other examples to follow in this case is B. First of all, combine like terms. We're gonna combine the p's on the left. Okay, let's combine the p's on the left, right? We combine the p's on the left. Okay, I think we need to do something else. Okay, we combine the p's on the left. 4p minus 1p give me 4p minus 1p give me 3p minus 11 on the left. On the right, we can combine the constant term. 2 minus 20 give us negative 18 plus 2p that we cannot get rid of. Now, we need to bring all the p's on one side and all the constant term on the other side. So we're going to do it step by step. Let's get rid of the 2p on the right and bring it to the left, right? So whatever I do on the right, I also do it on the left. So 3p minus 2p give me only p. I keep my 11 equal negative 18. 2p minus 2p give me 0. Now we need to have only p on the left. What we should do here? Yeah, we add 11. So add 11 to both sides. So we end up with p equal negative 18. If we have negative 18 plus 11, that gives us negative 7. Okay? All right. Let's go with C. I'm going to write C up there so you can see what we're really planning on doing. I'm going to take a green. I love green, so I'm hoping you can read it with it. The first thing to do with C is to combine. We combine the P's. What? That is the same exercise. I believe that it should be a different one. So I'm going to write which one it was because at this point, this is C. I'm going to remove that C because that's totally a different C, right? So if you have C as 3 times 3x minus 5 equal 10x, okay? This is the real C. Apologize for that. Hope you get it. Okay. First of all is this distribution. We must distribute. You must distribute. So we're gonna do this. We distribute the 3. 3 times 3x give us 9x. 3 times negative 5 give us negative 15 equal 10x. It's not all the time we must have x on the left. We can also have it on the right. If it's working for us, we can isolate x on the left. So what we can do here is subtracting 9x from both sides. So we have negative 15 equal x. You can either write it like this or you can change the equal to make it negative 15 like this. Either way, answer would be correct. All right. Solving equations containing fractions or decimal, that's very important to do. First of all, to solve linear equations containing fractions or decimals, you need to clear the equation of fraction or decimal by multiplying both sides of the equation by the least common denominator, LCD, of all denominators in the equations. We need to use the distributive property to remove grouping symbols such as parentheses or bracket. We also need to combine like terms on each side of the equations. We need to use the addition property of equality to rewrite the equation as an equivalent equation with variable terms on one side and numbers on the other side. So keep all your variables on the left or on the right, and keep all the constants on the other side. Check the proper solution in the original equations. Don't forget, you can always come back to verify your answers. If they ask you to solve something like that, the first thing I see here, there are 2 ways I can do it. I can either distribute, let's say for the first examples, I can distribute that 5, that 3. So it's make it that I would have like 3y plus 9, but still over 5. And on the other side, I'm going to have 2y plus 6. We said, remember the whole thing here is really over 1. Looking at both sides, what would you say the least common denominator is? Well, the least common denominator here is really 5. So you can multiply both sides by 5 to get rid of the denominator on the left. So when you multiply both sides by 5, the first thing you're going to see, these two 5s can be simplified because we have a product of two factors. 5 is a factor, 3y plus 9 is another factor. You can only simplify when you have factors, right? So on the left, I'm going to have left only 3y plus 9. On the right, I'm going to have 5 times 2 is 10y. Remember, distribute the 5 with this one and distribute it also with the 6. Plus 5 times 6 is 30. Okay, different ways of doing it, as I said. Because the largest coefficient for y is on the right, I'm going just to get rid of the 3y on the left. So I'm going to subtract 3y from both sides. I end up having 9 equal 7y plus 30. Now, let's suppose we need to get rid of that 30. We subtract 30 from both sides. So our 7y on the left keep us what with what? Yes, negative 21. Now, when we divide both sides by 7, we end up having y equal negative 3. That you can leave like this, or you can write it y equal negative 3. Answer would be the same, okay? We have two other examples that you can eventually do, or I can help you to do it. Let's see if I copy and paste the next one. And I erase all of this to show that we're gonna use for the next one. And I get rid of the, I'm gonna do B then because I feel like I cannot erase everything, really. All right, let's do B. To do B, first of all, with the 3x minus 7 equal 3 times x plus 1, what you need to do is really distribute the 3x plus 3, we distribute the 3. Now look, we must combine like terms. That means isolate the x on one side and the constant term on the other side. So we need to subtract 3x from those sides to bring all your x's on one side. Now, what you see by combining the like terms, we eliminate the x. So we have 0x minus 7 equal 3, or we have negative 7 equal 3. No x's. We don't have any x's. So that's how we recognize identities equation with no solutions. All right. So what happened here, we eliminate x. Now, is it true that negative 7 is equal to 3? No, that's false. That's totally false. That's a contradiction because negative 7 is not equal to 3. Since no value for the variable x can be substituted into the equation that will make this a true statement, you said no solutions. Right? There is no solution. So a solution set is written with as if you were supposed to write the solutions, you're going to write it either like two parentheses like this, two brackets like this, or you could write the solutions as empty. So that symbol means empty set. So we have that symbols where we said, so this equation is a contradiction. Equation is a contradiction, all right? Now, Let's try the next one. I'm going just to copy paste for the next one as well. Let's copy paste for the next one. I'm going to erase this part, but know that we're gonna do C because it seems like I try to fix it, but it doesn't work. But when we do C, first of all, if you keep the left side the way it is and you distribute the 2x with what you have inside of the parentheses, now, next, you can combine on the right. Keep the left as is, okay? But the right, you have 2x plus 3x give you 5x. And you have 2 minus 7 give you negative 5. Now, let's combine. We're going to subtract 5x from both sides to get rid of the x on the right. Oops, by trying to do that, look at what happened. We have negative 5 equal negative 5. Do you feel like, now, if we try to get rid of the constant term, we're going to add 5 to both sides. You see what happened? Now, do you think the previous equations, B and C, they are equivalent? Is that a contradiction? No, it's not a contradiction because it's not like you have a false statement. In the previous one, we have negative 7. Okay, in the previous one, we got negative 7 equal 3. That was not true. It's false. Negative 7 is not equal to 3, positive 3. But here, 0 is really equal to 0. That's true. Okay, it's true because both sides of the equations are identical. And since this equation will be true for every x that is substituted into the equation, we can say the solution is all real numbers. We said solution is all real numbers. Or we can say solutions is something like that. If you can just put an R to say it like this, or you can say solution, I'm sorry, I put parentheses, is negative infinity, infinity. Or you can say solutions is x such that is the set of all x such that x is a real number, such that x is a real number, okay? Now, these equations right here is called an identity, okay? Equation is an identity. So we have three possible equations. Conditional equations is when you solve, you obtain something for x. Contradictions is when you solve, you eliminate x, like involuntarily. And then the number you have on the left is not equal to the number you have on the right. So it's a contradiction and there is no solutions. Or you solve the equations by trying to solve for x, you eliminate x, but the number on the left is equal to the number on the right. So it's true for all value of x. Then the equation is an identity and the solution is all real number at some point. So hopefully this introduction to equations help you to start chapter 2 as quick as possible, because we covered linear equations in one variables. We're going to come back with more of equations in another video. Let me know if you have any questions. I'll see you soon. Take care.